Chemistry, the scientific study of matter, its properties, and how it changes. But in my opinion, chemistry is the study of matter. Matter, anything that occupies space and have a mass. Matter can exist in three states, that is, solid, liquid, and a gas. There's a fourth state of matter called plasma. Now, plasma is something else, and there might be another state of matter that can be discussed on further on later theories. The word chemistry is derived from the word chemical, which already refers to a chemical reaction. Types of reaction: physical reactions and chemical reactions. Physical reactions: the changes in matter where the substance's identity remains the same, but its physical properties like size, shape, or state are altered. Chemical reaction: a process where the substance reactants are transformed into new substances, products, by rearranging their atoms. Examples of physical reactions are melting, freezing, boiling, dissolving, etc. Examples of chemical reactions are like combustion, rusting, acid-base reactions, and redox reactions, etc. So, in today's video, I will undergo several physical and chemical reactions in order to understand the main basis and common concepts of chemistry. The main basis of reaction. The reaction may be exothermic or endothermic. Exothermic reaction. The word exo means outside, which obviously means the reaction which gives out heat from its surroundings. Examples are like dissolving sodium hydroxide in water and burning a mixture of iron and sulfur. Endothermic reactions. The reaction in which heat is absorbed from the surroundings is known as an endothermic reaction. Examples are like melting of ice, evaporation, and cooking of an egg. So now let us perform one of each of these chemical and physical reactions. So, in chemical reactions, the first exothermic reaction that I'm going to perform right now is burning a mixture of iron and sulfur. To do this, I basically took out a scale and measured about 1 grams of iron. Now I transferred this iron into a test tube, and right after this, I measured about 1 grams of sulfur. Then I added both of them into a small beaker and mixed them thoroughly, after which I placed a magnet downside of the beaker. This is because the iron is magnetic and it can be easily removed from this mixture. Mixtures can be of two types, which is a homogeneous mixture and heterogeneous mixtures. The word homo means same and hetero means different. The mixture that contains same type of molecules and substances inside of it is called a homogeneous mixture. A mixture that contains different type of molecules and substances inside of it is a heterogeneous mixture. What I have over here is a heterogeneous mixture of iron and sulfur, and it can be easily removed physically by just using a magnet, which can easily help me remove the iron from the sulfur. The iron inside of it forms these beautiful spikes, and it is quite mesmerizing to watch it. After this, I transferred both of them into a test tube, and the next step that I have to do is to just burn it. To do this, I basically lighted a spirit lamp and then I placed the test tube inside of a test tube holder. I holded the test tube right over there and started burning the iron and sulfur. Almost immediately, the iron and sulfur started reacting and turning black, undergoing an exothermic reaction, which is basically iron is reacting with sulfur to make the black iron sulfide. The iron sulfide which is being produced over here is producing a lot of sulfur dioxide gas. Now this reaction is required to be taken under a fume hood or a well-ventilated area. This is because sulfur dioxide fumes are quite bad for the human health. After this, I let the reaction die down, and once the tube had cooled, I broke the tube and released the black iron sulfide from inside of the tube. I crushed it up into a powder, and when I checked, it was no longer attracted to a magnet anymore. Now, this was an example of an exothermic reaction. The second example for an exothermic reaction is adding sodium hydroxide drain cleaner into some water. To do this, I basically took a beaker and I filled it up with some water. Underneath it, I kept a stir bar and I suspended a thermometer. Then I noted the initial temperature, which was only about 10 degrees C. This constant temperature was going on like this until I added some sodium hydroxide inside of the water. Almost immediately, there was a sudden change in temperature, and right after when the sodium hydroxide was mixing, almost immediately, the temperature started rising. I set it on a time lapse and I saw the difference inside of the temperature. Now over here the temperature was almost spiked from 10 degrees C to almost over 18 to 19 degrees C. This obviously meant that an exothermic reaction has occurred, and obviously this meant the reaction that happened over here was an exothermic reaction. Now over here, sodium hydroxide is quite corrosive to the skin and eyes. Make sure to wear proper safety goggles, lab coat, and gloves in order to handle these chemicals. Now let us discuss about endothermic reactions. Obviously, the word endo means inside, in which the heat is absorbed from the surroundings. The first example is like melting of ice. This can be also done by your own self. All you have to do is to just take some ice and place it inside of a container and then just leave it out in a room temperature. This is because the melting point of ice is only about 0 degrees C. It is going to absorb heat from the surroundings, and this will result in endothermic reaction in which the solid ice is then converted into a liquid. The second example is evaporation. The process of liquid turning into a gas also absorbs heat from its surroundings. This can be also absorbed by our own selves when water is being boiled around our surroundings. The third example is cooking of an egg. Similarly, cooking an egg absorbs heat from the pan, or boiling it in water changes from a liquid to a solid by absorbing some heat. Now let us discuss about physical reactions. The physical reactions rely on this chart. Various concepts can explain physical reactions in matter. Scientific concepts used in chemistry are like distillation, diffusion, solubility, and physical properties. Distillation, the process of separating a liquid mixture by using the difference in their boiling points. This is quite done by myself, and I will use this in further on later projects. Diffusion, the spontaneous mixing of molecules from a higher concentration to a lower concentration. Solubility, the term used in chemistry where like dissolve like, indicates polarity where polar substances dissolve in polar and nonpolar dissolve in nonpolar. Physical properties. These include like weight, density, volume, mass, conductivity, etc. Now, this was only about the basics of chemistry, and these concepts will be used on later on projects. If you like watching videos like these, make sure to consider subscribing, and I will see you in the next one. Thanks for watching.